Function p is defined by polynomial. Some values of x and p of x are given in the table below. Which of following must be a factor of p of x? X minus 3, x minus 2, x plus 2, or x minus 1. So we know that the expression x minus a is a factor of polynomial p of x if p of a is equal 0. Value for our polynomial for a is 0. So let's see what we have given here. We have x minus 3. So let's check the value of our polynomial for 3. What will be for 3? The value of our polynomial is negative 2, is not 0, should be 0. So this is not factor of our polynomial. Why? Because x minus 3 is not factor because p of 3 is equal negative 2. Should be equal 0. What else? Next we have x minus 2. Let's see the value of our polynomial for x equals 2. For x equals 2, we have that our polynomial has value 0. So for x equals 2, we have that p of 2 is equal 0. So what we can say? That x minus 2 is a factor, so it means that x minus 2 is the factor of p, of our polynomial p. One more time, why? Because for x equals 2, the value of our polynomial is 0, and we know that x minus a is a factor of polynomial p if value of our polynomial for a is equal 0. For x equals 2, value of our polynomial is 0, so x minus 2 is factor. What next? We have x plus 2. So here we have like x plus 2, so we can rewrite that this is x minus negative 2. So in this example, we have that a is equal negative 2. We don't have value of our polynomial for negative 2, so we cannot say anything about this expression. Let me write, because we don't have x equals negative 2 in our table, so we cannot say anything about this expression. And next we have x minus 1. For x equals 1, the value is 2, is not 0. So this is also not factor of polynomial, and x plus 2 is also not factor of our polynomial. Why? One more time, because we don't have value of our polynomial for x equals negative 2. So this is my solution. The answer is x minus 2 is factor of our polynomial p of x.